This is lesson 1.5, rational and irrational expressions. We're going to be focusing on learning target 1.3, which says that I can explain why sums and products of numbers are rational or irrational. So before we start into the actual expression, let's take a quick review of what rational and irrational numbers actually are. So this is a great explanation of what irrational numbers are. They are the mumbo-jumbo numbers. They are any decimals that never end and have no pattern. So this does not include repeating decimals. But it would include numbers like pi. That would be a irrational number. This would include numbers like the square root of 2. If you type that in your calculator, it would give you a ongoing decimal that never repeats and never ends. And even though in your calculator you cannot see that, it actually has to end at some point. We know that the square root of any non-perfect square, so the square root of 2, square root of 3, the square root of 21, any non-perfect square is an irrational number. So these are just all of the decimals that never end and have no pattern. Okay, you can think of it as the mumbo-jumbo numbers. There's not any categories under irrational numbers, and there's not many of these that we really work with. Most of the numbers that we work with are rational numbers. And the big thing about a rational number is that it is a ratio, which means that we can write all rational numbers as fractions, no matter what form that they are in, they can be written as a fraction. And this includes all fractions and any decimal that either ends or repeats, has a pattern. So an example of a rational number is the number 6. It's just a simple whole number that is a rational number. The fraction 2/3 obviously is a rational number because it's already written as a fraction. Decimals that end, like 2.5, those are rational numbers. And even square roots of perfect squares, like the square root of 16. The square root of 16 is equal to 4. That is a rational number. So anything that comes out to be nice and neat, or is a decimal that ends or repeats, or is a fraction, those are all rational numbers. These other categories we're not super concerned with. Integers, just know that that includes all negative and positive whole numbers. -2, +8, 0, all of those are integers. Whole numbers, we just consider these to be the positives and 0. So 0, 1, 2, and going forward. And natural numbers, these are everything that we count with. So it's all of the whole numbers except for 0. We start with 1, 1, 2, and 3. So those are the big things that we need to focus on for this are just the rational and irrational numbers. So most numbers that we work with are rational numbers. We work with rational numbers way more often than irrational. And it's also important to remember that all square roots of non-perfect squares, are irrational numbers. Remember, your perfect squares are 1, 4, 9, 16, 25, 36, so on and so forth. This is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. So those are perfect squares. Square roots of non-perfect squares are irrational. So let's look at the rules for rational and irrational expressions. So a rational number times another rational number. Well, we could think of an example, and we'll keep this simple. We'll say that we're going to do 4 times 3/4. Well, 4 times 3/4, that would be 4 over 1 times 3 over 4, which equals 12. over 1 times 4 is 4, and that's equal to 3. Well, it's obvious that 3 is a rational number. And in fact, anytime we have a rational times a rational, it's going to stay rational. Rational times a rational is a rational number. Similarly, with rational plus rational, let's say that we had 8.2 plus 9.1. Those are both rational numbers. Well, 1 plus 2 is 3, and 9 plus 8 is 17. That's equal to 17.3. That's still a decimal that ends, so this is still a rational number. So as long as we have all rational numbers, our answer is going to stay a rational number. On the flip side of that, once we throw in the irrational numbers are like the monsters. They are going to eat the rational numbers. Okay, they kind of take over when we're working with irrationals. If we think about the expression 2 times pi, well, that's just equal to 2 pi, and I can't simplify that. I can't stop it from going on forever. That's a number that goes on forever and ever and ever. That is irrational. That's irrational. So if we have an irrational number involved, it's going to be an irrational answer. Similarly, if we have, let's say, 5 plus the square root of 7, we've learned that we cannot add square roots of things together unless they have the same number under the square root. So this would just have to stay as 5 plus the square root of 7. A rational number plus an irrational number is going to be irrational. So those are the rules that you need to make sure you put to memory, is that a rational times a rational is rational. A rational plus a rational is rational. As long as it's all rational numbers involved, it stays rational. A rational times an irrational is irrational, and a rational plus an irrational is irrational. Anytime we have an irrational number involved, our answer is going to be irrational for our cases. Try the practice on the back side of that page, and if you have any questions, please bring them to class.